Okay, welcome back. Before we start to build the skeleton which will drive our creature, I wanted to first go over some of the fundamentals of joints. It's important to get a good understanding of how joints work in Maya and realise there is a lot more to them than simply being nodes which push vertices around. If you already have a good grasp of rotational axes, rotation orders and gimbal lock, then please feel free to skip this video. I would, however, recommend you watch it just in case there are any tips or tricks you may not have heard of before. Okay, let's start with joint creation. There are a number of ways to create joints in Maya. First, we can use the main menus. We need to make sure the menu set is set to rigging so we can see the skeleton menu. Now we can see it, we simply move down to create joints and open the options. Just reset this so it's back to the default settings. So here we have the main options associated with creating joints and joint chains. I don't want to cover all of these in this video. Instead, I will focus on the more important areas here, and we can discuss the others as we build the skeleton later in the course. You will notice that the mouse pointer has now changed to a crosshair, which indicates we are in joint creation mode. What I like to do is snap the joints to the grid, just to keep things neat and tidy. To do this, I can simply hold down X, which will activate grid snapping. You can also see the button being activated up here. What I can do now is click anywhere and the joint will snap to the closest grid point. I can then click over here and create a second joint, and then a third. To complete the joint chain, I just press Enter and then we drop out of joint creation mode. Here we have a simple joint chain with each joint being automatically parented to the one before it. You can see the hierarchy in the outliner. So that is one way to create joints. The next is to use the rigging shelf. The Create Joint button is here, and to open the options we simply double click it. You can also see the last used tool is shown here for quick access. And we can create joints just as before. Finally, you can hold down space to access the skeleton menu through the hotbox. Okay, now let's dig a little deeper into the world of joints. Here you can see we have a series of orientation settings. These control how the joint's axis will be created. If I enable Orient Joint to World, you see the other options become disabled. What this is going to do is create each joint but make its axis match the world axis, so the axis you see down here. Let's create 3 joints again. I'll do them like this, so it represents an arm with the shoulder, elbow and wrist. Now if I select the joints, you can see that the axis is the same as the world axis. Usually when joints are created, the axis is automatically adjusted so the joint points to the next one in the chain. So having the axis set up like this is no good for our joint chain. If I twist the root, you will see that the elbow moves up and down, but we need it to remain still and just rotate or twist with the root. So we just want it to turn and not change position. The same with the middle joint or the elbow joint. Rotating this causes the wrist to move. Okay, let's delete those and add in the correct orientations. And let's turn this off now. Let's create the chain again, but with these default settings. You see, Maya has now adjusted the orientation of each joint for us. So the X-axis is now pointing towards the next joint. What this means is I can now twist the root joint and the elbow joint rotates, but doesn't move up or down. So this is more like how your shoulder would work. The same with the next joint. Okay, so let's look at what the settings do. The primary axis is the one which will point towards the next joint in the chain. The secondary axis points away from the joint. Finally, the secondary axis world orientation tells Maya which way you want the secondary axis to point. It uses the world axis as a guide, so setting this to Y means the secondary axis will point up wherever possible. You can also use this drop-down box to invert the direction if needed. Let's build the joints again so you can see what these do. So here you can see we set secondary axis to Y, and it's pointing up because secondary world axis orientation is also set to Y. The primary axis is X, just as we specified in the settings. The Z-axis isn't set because its position is purely dictated by the primary and secondary axes. What's good is we can change this completely. So this time let's have Y pointing down the joint. The secondary axis has automatically jumped over to Z because we can't have the primary and secondary axes pointing in the same direction. Let's change this to X actually. Now we need to decide which way we want X to point. We can leave this set to Y because we want the X-axis to point up. Let's create some joints and see what we have. So there we now have Y pointing down the joint, and X is pointing up. Perfect. Okay, let's do this one more time. So I want Z pointing down the joint this time. I want Y to be the secondary axis, and that should point to the right or along the world's X-axis. So now we have the X-axis pointing up, and that's because we told the Y-axis to try and point to the right. Because the joint is already pointing right, it's trying its best to go there, but this is as far as it can go. So that's how to set up your rotational axes. Okay, let's reset this. If you build your joint chain and then decide you want to change the orientation of the joints, you don't need to rebuild everything. You can use another tool to help. Let's build the joint chain again. And close this. Let's imagine you're building the skeleton and you need to reposition the joints. So let's move this to here. And this here. Maybe down slightly too. And move this up here. As you can see, manually moving the joints has broken the orientations, so each axis is now misaligned and no longer points to the next joint. So essentially, the rotations won't work as we would expect. You see, we've lost the nice twist we had. It's not an issue though. All we need to do is go to Skeleton, Orient Joint and open the options. As you can see, this is exactly the same as the section we had in the Create Joint tool. I'll just reset it. So you see, we have the same options here to control where each axis will point. We can tell the tool to also affect all the children of the selected joint, so the other joints in the chain. If I apply this now, the orientations are corrected, using the settings in the tool as a guide. So X is now pointing down the joint again, and Y is pointing up. The twist is fixed. It works here too because we told it to also update the selected joint's children. We can also completely change this setup if we like. So let's switch to Y being down the joint, and we will leave Z pointing up. That's updated. Good. As you can see, it's dead easy to correct the orientations if you need to. The only joint it won't affect is the last joint in the chain, simply because that has nothing to point towards. What we can do with this though is instead tell it to match the previous joint's orientation. This is essential if this were to be a wrist joint, for example. All we need to do is enable Orient Joint to World again, and apply that. Because this is already a child of a joint, it will just inherit its parent's orientation. So that now matches this one's orientation. Okay, let's close that. If you did want the end joint to have a different orientation, simply create a temporary child to that joint, fix the orientation, and then delete the temporary joint. There are times when you will want to be able to see a joint's orientation without having to select it. To do this, select the joints, and go to Display, Transform Display, Local Rotational Axes. We can now see which way each axis is orientated. What this also allows us to do is go in and manually adjust each axis, rather than it being done automatically. There are plenty of times you will need to do this because the Maya tools don't always get the joint's axis pointing the way you want. You will see this as we build the creature's skeleton. What we need to do first is switch to component mode using this button here. Now move over to the miscellaneous components button. This is the one that looks like a question mark, and right click. Select local rotational axes. What this allows you to do is select the axis itself. It will turn yellow when selected. You can then adjust it like so. Let's say we need it to point more in this direction. So you can see that the orientation has been changed, and we can rotate it around a new axis. This does leave us with a problem though. If I select the root joint, you will see that the rotation and translation axes both match. Even the scale axis is the same. If we zoom in a little, you can see that we changed the rotational axis, but the translation axis hasn't changed, so it's different. So this and the scale axis need updating too, or it will cause issues with the rig. If I look at the joint's attributes, you can see here there is now a value of -57 on the rotate axis. This is essentially an offset we added when we edited the axis. Having this value here isn't ideal. Like I said, it can cause problems with the rig, but more importantly, when the skeleton is exported to a game engine, the animation won't come through correctly. So we ideally need to clear this value, maintain our orientation, and also make the translation and scale axes match the new orientation. The problem is, there is no magic button or tool to fix this yet in Maya. On the bright side, it is a very easy fix, and all we need to do is use a bit of Mel script. Open the script editor. Now don't worry if yours looks different to mine. I prefer to use a plugin which enhances my script editor. This is because I do a lot of scripting. All you need to do is type joint -e -ZSO. All this is going to do is edit the joint and reset its scale orient, which will also reset the translate axis too. If I select the code now and press enter to run it with the joint selected, you see the translation axis resets to match the rotation one. That fixes the problem. The scale axis is corrected too. We have also zeroed out the rotate axis values too, so the joint is now clean and tidy and ready to be passed to a game engine. Okay, so that's the rotational axes covered, and we will see more of this in action in the next video. Let's now look at another important area of Maya's joints, and that's their rotation orders. First, let's build another basic joint chain. We will use the default values for this. This will do. As you rotate a joint in Maya, you will see that each axis, red, green and blue, all follow as it moves. They all stay locked, equally distanced from each other, which makes animation so much easier. The problem is this is all a lie. We aren't actually looking at the correct axes. If I hold down Ctrl and Shift, and then right click, we get this marking menu. In here, we can change how the manipulator looks and how it works. Let's change this from Object to Gimbal. You will see that the blue circle has now disappeared. What you will also notice is that you can't manipulate the joint now, not without selecting an axis. Now if I rotate the Y-axis, the red X-axis follows, but the blue Z-axis doesn't. But if I select the Z-axis and rotate that, the other two follow it. What's even more confusing is if I switch to the X-axis, neither of the others move. So what's going on? What we are seeing are the true rotational axes. So instead of them all moving as one, what you can see is that they are in a hierarchy of their own, much like our joint chain. In this setup, Z is the parent axis. Y is then parented to this, and then X sits at the end of the chain, so it has no children beneath it. So this is why Z moves everything, Y only affects X, and X doesn't alter the other axes. It's because of this setup we can do something like this. If I rotate Y to this point, you will see that the X and Z axes are overlapping. And this is gimbal lock, when two axes occupy the same plane. So essentially, both rotate the same way, locking this joint until the Y-axis moves again. So how do we get around this issue? Unfortunately, there is no easy fix which will work in all situations, not without creating a complicated system of nodes anyway. What we can do though is change the hierarchy so we can dictate which axis will affect which, and we can do this with the rotate order attribute. By default it is set to XYZ, and this is almost the reverse of what the hierarchy is representing. So X is actually at the bottom of the chain, Y is in the middle, and Z is at the top. There are lots of other options for you to experiment with. Let's try the next one down, Y, Z, X. So this should mean that Y is now at the bottom of the chain, then Z, and then X should be at the top and affect everything else. Okay, so Y doesn't move anything else. Z moves Y, and X moves the others. Okay, let's try another. Z, Y, X. So this time Z has the least control, Y is in the middle, and X is the dominant axis. So you can now see how that changes how the joint rotates. The idea is that you would set this up to minimize the chances of gimbal lock. So you work out which axis will be used most often, and then set the rotate order to reflect this. So if this were an arm, we would use Z to lower the limb, and then we can use Y to move it forwards and backwards, leaving X to be used as the twist. You see, we still do hit that lock here, and it's important to say that you will never completely avoid it. What you can do is set the rotate order to reduce the chances of it happening. Don't spend too much time worrying about each and every joint though in your character. In most cases, the default XYZ will be fine because most joints will only need to rotate one particular way. The elbow, for example, should only need to move like this, but even then we hit a lock at this point. So in this instance, we know that Y is the primary axis, so we can change the rotate order to ZXY. That fixes it. This is just something to keep in mind as you're building your skeleton. Work out which axis is the most important and update that rotate order accordingly. Don't worry too much though. You can change this later, so long as no animation has been done using the rig. Changing the rotation order after it's been animated will break the animation. Another important thing to mention is that all your controls and offset groups, if you use them, should also have the same rotation order as the joints they are moving. There are a couple of other options which you might find useful when building your joint chains. The first is symmetry. This is off by default, but when active, this will automatically create the joints on the opposite side of the character for you. This is what happens with it disabled, as you already know. If I set this to X-axis, it will mirror the joints along the X-axis here. If I create the joints now, you can see the opposite side has been created too. What's even better is we can move this side and the other follows. So it's a proper mirror image. We can rotate it too, and it follows. So you can see how this could help speed up the process of building a skeleton. Let's create another and mirror across the Z-axis instead. And that's done. If we look in the outliner now, you can see that the opposite skeleton has symmetry constraint nodes attached, which are what makes the symmetry work. The problem is, these also lock the joints, so you can't rotate them or translate them. You can see they are locked by a direct connection with the yellow tags on the channel box, so they will only follow where the original joints lead them. If you do want to get control of them again, all you need to do is delete the constraints. That grants them their independence, so you are then free to do what you like with them. There's one more area I want to quickly talk about concerning joint creation, and that's the projected centering option. What this will do is automatically place the joint in the middle of the model. If we look at the arm, with this enabled, I can simply click on the shoulder to place a joint, and Maya will work out the central point of the model for me. It would help if we could see the joints. So let's just enable X-ray joints so we can see the joints through the model. Okay, that's better. There it is, a tiny joint. Now let's create one for the elbow. And finally, another for the wrist. So there you can see Maya has done a pretty good job of placing these joints for me. Where this tool really shines though is with fingers. Ideally, I'd show the wireframe so I could see where the knuckles are, but this is just a demonstration. So that's one finger done. Okay, let's create the others. As a tip, you can press G to jump back into the last tool you used. So in this instance, I can just press G to reactivate the joint tool. And that's the thumb done. Okay, that's the joints for the hand done. Yes, we would need to go in and adjust them further and also make sure they are orientated the right way. But this gives us a good starting point. With areas like the arms, legs and fingers, the tool works well, but it does fall down when attempting something like the torso. I'll just create a few quick joints to demonstrate. As you can see from the front, they aren't aligned correctly. Ideally we need them straight. So in this instance, it would be better to create them with projected centering disabled. Okay, so that's the fundamentals of joints covered. In the next video, what we're going to do is we're going to start building our skeleton.